Hello, this is section 2.5, the product rule. Product rule states, if f of x equals u of x times v of x, in other words, the product of two functions, then f prime of x is equal to u prime of x times v of x plus u of x times v prime of x. In other words, the derivative of the first function times the second function plus the first function times the derivative of the second function. Example 5. Find the derivative of y equals 2x cubed plus 3x plus 1 times x squared plus 4. Well, here, the 2x cubed plus 3x plus 1 would represent our first function, or u of x. X squared plus 4 represents our second function, or v of x. So then y prime is the derivative of the first, 6x squared plus 3, times the original second, so x squared plus 4, and then plus the original first, times the derivative of the second. And it is okay to leave your answer in this form. Example 6. Find the equation of the tangent line at x equals 1 for f of x equals this function. Now, remember, tangent line, we are thinking y minus y1 equals mx minus x1 because it said line. My x1 is 1, so to find y1, I plug that in, so f of 1 would equal 4 plus 5 minus 6 plus 5 times 1 minus 4 plus 1, which is 8 times negative 2, or negative 16. So that's my y value. So then the only thing that's left is we need the slope of the tangent line. And if you remember, the definition of the derivative is the slope of the tangent line. So I'm going to find f prime of x. And since f of x is the product of two functions, I am going to take the derivative of the first, times the original second, plus the original first, times the derivative of the second. And you move this over. So that would be 3x squared minus 8x. Now, thankfully, we aren't expected to expand this out, because that could be tedious. I just need to find the slope at 1. So I'm going to plug 1 in for x. So that's 12, 10 minus 6, times 1 minus 4 plus 1, plus 4 plus 5 minus 6 plus 5, times 3 minus 8. So we get 16 times negative 2, plus 8 times negative 5, which is negative 32, minus 40, which is negative 72. So now my equation is y minus negative 16 equals negative 72, x minus 1. And the only thing I would simplify is this would be y plus 16 equals negative 72 minus 1. And there's the equation of our tangent line. Now, depending on my open math, it may say solve for x. So just read the directions carefully. The quotient rule. So now instead of f of x being the product of two functions, it is the quotient of two functions, u of x and v of x. And then f of x is the derivative of the first times the second, minus the first times the derivative of the second. So notice this is similar to the product rule, just with a minus instead of a. But then don't forget you have to divide by the second function squared. So example 7, find the derivative of y equals x squared minus 4x over x plus 5. So top function is u of x, bottom function is v of x. So then y prime is derivative of the first, x minus 4, times the second, minus the first, times the derivative of the second, which is just 1, all over the second squared. Now this one, I would be okay with you leaving it that way, but because of the 1, I normally probably would simplify this. So that becomes 2x squared plus 10x minus 4x minus 20 minus x squared 4x or 5 squared, which is 2x squared minus x squared is x squared. Negative 4x plus 4x cancels out, so plus 10x minus 20 all over x plus 5 squared. And there's our answer. Example 8. Find the equation of the tangent line at x equals 3 for f of x equals this. So again, we are thinking, because it says tangent line, y minus y1 equals mx minus x1. Well, x is 3, so to find y, I just go f of 3, which is 27 minus 27 plus 2, all over 9 minus 4, which is 2 over 5. And then again, to find the slope, we need to find the derivative. So f prime of x is 3x squared minus 6x, because that's the derivative of the top, times the bottom, minus the top, times the derivative of the bottom, all over bottom squared. And then to find our slope, we plug 3 in, so f prime of 3 would equal 27 minus 18 times 9 minus 4 minus 27 minus 27 plus 2 times 6 all over 9 minus 4 squared. What does that come out to be? 9 times 5 minus 2 times 6, 5 squared, which is 45 minus 12 over 25, 33 over 25. So then our equation is y minus 2/5 equals 33 over 25, because that is what our m value is, and then x minus 3. And that is the equation of the tangent line. And finally, we have the chain rule. So we talked about adding, subtracting, multiplying, and dividing, but remember, when you're talking about functions, there's a third operation called composition. So if h of x is the composition of f and g, also written as f of g of x, then h prime of x is f prime evaluated at g of x times g prime of x. So in other words, it's the derivative of the outside, do not change the inside, times the derivative of the inside. So for example, f of x equals 3, 2x minus 1 squared, the outside function, is 3 squared. You can think of the parentheses as x, but that is what's going to contain the inside function, which is 2x minus 1. So f prime of x is the derivative of the outside, so I drop the 2 down, so 2 times 3 is 6. Subtract 1 from the exponent, so to the 1, and then times the derivative of the inside, so 2. But we usually do not leave a set of parentheses blank like this. And that's where this part of the formula comes in, is it just stays the inside function, 2x minus 1. So this would equal 12x minus 6 times 2, which is 24x minus 2. B. Well, our outside is just the square root. But remember, that's the same thing as saying something to the 1/2 power. And then our inside function is x squared minus 1. So then y prime is the derivative of the outside. So that would be 1/2 to the negative 1/2, because 1/2 minus 1 is negative 1/2, times derivative of the inside, which is 2x. And then again, this blank parentheses gets the inside function plugged. Now here there isn't much you can do besides the fact that 1/2 and 2 will cancel out. So I would just rewrite this with the x in front, x squared minus 1. Now C, you can kind of think of it as a quotient rule if you really wanted to, or you rewrite it, it's the same thing as this. Oh, forgot the squared on the cube. So then we can use the chain rule, because in my opinion, the chain rule is a lot quicker to use than the quotient rule. So here, our outside function is the 4, and then parentheses to the negative 1. And then our inside function is the 3q squared plus 1. So p prime would equal, do the derivative of the outside, so negative 4, subtract 1 from 1, so negative 2, and then times the derivative of the inside, which is 6q. And then the inside goes back in the parentheses. So we get negative 24q, 3q squared plus 1 to the negative 2. But if you want to make it look like the original answer again, you could rewrite it as negative 24q over 3q squared plus 1 squared. And in the spirit of what we did for part C, for part D, the first thing I'm going to do is bring that up as x squared plus 1 to the negative 3/2. Now you might ask, where did the square root go? Remember, the square root is the same thing as the 1/2 power. So when I do 3 times 1/2, that's where the 3/2 is coming from. And then I brought it to the top, so that's why it's negative. So our outside function is just the negative 3/2. And our inside function is the x squared plus 1. So then g prime of x is negative 3/2, and then blank to the negative 5/2, because negative 3/2 minus 1, times 2x. And then x squared plus 1 goes back in the inside. Well, this 2 will cancel out that 2, and we're left with negative 3x, x squared plus 1 to the negative 5/2 power. Again, if you wanted to look like the original function, you could rewrite it. And that is it for section 2.5.